This recording brought to you by the University of Adelaide.
I almost never do this, but on this occasion the only way I'm going to finish in anything like my time is to read a talk. So excuse the lack of impromptu comments that are forced by that. In just half an hour it's impossible to do justice to the activities of the large number of remarkable scientists who've contributed to the history of physics here. Rather, my aim is to present some personal recollections of key moments in the development of physics from the time I arrived to the present day. Clearly with an emphasis on theory, because that didn't exist in physics before 1984 in the physics department. The icing on the top of my talk will be a brief summary of the current research highlights, and that's fortunately a real pleasure. It's fair to say that in terms of its research, physics is today stronger than it's ever been. Flawed though the ERA ranking may be, the fact that the discipline as a whole was ranked 5, with 2 research areas ranked 5 and another ranked 4 is a fitting testament to that strength. At my appointment, and you'll have to excuse me here because I'm not an historian and I keep discovering bugs. At my appointment in 1983, I was 33 years old. That's correct. At the time, the second youngest professorial appointment. Well, in physics, as we heard today from Peter, Bert was 29 when he was appointed in maths physics. With Bragg appointed at 23, it's doubtful anyone else could ever take the record as the youngest. Of course, in this century, Tanya Munro, appointed at age 31, took over second place in physics at least. Now, sadly, the origin of my appointment lay in the death of David Sutton, about whom much has been written and whom I did not know. At the time, the department requested the release of a lecturing post. However, John Bowie, who was Dean of Science, took the bold and in a sense selfless decision, because at that time a more expensive position in physics almost certainly meant one less position somewhere else on the faculty. He took the position that the department was in need of the leadership that could only come through a professorial appointment. Now, the appointment of a full professor at that time was a remarkable process. There were 5 candidates all at the university in the same week, circulating one after the other between the lecture room and the offices of the Vice-Chancellor, Don Stranks, the Registrar, Frank O'Neill, the Bursar, David Beecher, and of course Harry Medlin. It's a pity Harry isn't here because David Beecher gave me the secret to getting the job. Make sure you talk to Harry Medlin. 2 of the other candidates were Eric Weigold and Bruce McKellar. Now, they were both fellows of the Academy of Science and very senior figures. And I have to tell you one remarkable story about my own candidacy. I was a staff member at CERN, and I was attending a conference in Los Alamos, which was also attended by Bruce McKellar, who was a long-term colleague and friend. And in fact, in 1981, I'd spent 3 months study leave in Melbourne as his guest. At the end of the meeting, I accompanied Bruce to the airport, and at that time you could just walk out onto the tarmac and say goodbye as someone got onto the plane. I was about to board when Bruce asked me whether I was aware of the chair being advertised at the University of Adelaide. When I said I was not, he informed me, okay, the deadline's gone, but Frank O'Neill will accept an application. It was only after I was shortlisted and saw the other names that I realised how generous Bruce had been, given that he was also on the shortlist. Maybe he really wanted to stay in Melbourne. Now, the appointment committee included Professors Ian McCarthy and Angus Hurst, as well as Harry Medlin and of course Graham Elford and a number of others. And of course the Vice-Chancellor Don Stranks. I remember promising to lead the department by example, and obviously choosing youth in place of experience, they gave me the chance. Now, my arrival in 1984, and this is from 1984, so I hadn't been here very long, and it's remarkable to see this group of people. From the point of view of theory, I'll point out one person, Pierre Guichon here from University of Lyon, was one of the first overseas visitors that we had, amongst many since. And at that time, to come as a visitor, I think the invitation was actually written by the registrar. It was fascinating how things have changed over time. Okay, so my arrival in February '84 was greeted by a sense of excitement, mine, and perhaps some others, but also soon afterwards considerable unease. The Department of Physics, which was no longer regarded as a research powerhouse, had never had a theorist on staff, so I was a completely unknown quantity there. The Department of Mathematical Physics, which did have a distinguished history of research in both theoretical and mathematical physics, was in crisis with an FTE student load which at the time justified only half of its complement of 4 staff. I was simultaneously seen by those members of maths physics as a valuable colleague and a tremendous danger. At the time, neither department earned significant research funds. I think, as I remember, there was only one research associate in each department. I was astonished in looking through the papers from the time just how difficult the initial few months were. Indeed, when I look over the history of the discipline, I'm struck by just how incredibly unhelpful and at times damaging reviews can be. A review of the departments of physics and mathematical physics had been completely organised long before I arrived. The reviewers had been carefully chosen and were loaded for bear, and I was the guy in the fur coat. While having little to say and none of it positive about physics, the sole purpose appeared to be to ensure the separate survival of mathematical physics with a complement of 4 staff. My modest proposal, remember I was a fairly young and raw professor who could have used a little help, was to create a viable theory group of 2 to 3 staff, some postdocs and students, as well as visitors. That met with little enthusiasm from the review committee. In response to a more ambitious proposal to secure a high-energy research institute for Adelaide, federal funding around $500K per year, and I had support from the Director General of CERN at the time with a promise of $50,000 to $100,000 a year, the committee simply remarked there were better claims for such an institute. It was to take a further 27 years to realise that ambition. The result of this misguided review was a great deal of heartache for many people and much wasted time over the following 4 years. In contrast with the review committee, the head of department, Graham Alford, who's sitting here and looking very pleased with himself, as he should, was a wonderful mentor. He provided unfailing help and support. He carefully calculated the research income that would be associated with the group I'd proposed to build, and at the time it was the grand sum of $10,000 a year. And somehow he made it available so I could get a research program started. Don Strank's advice that I should expect to win 2 postdoctoral fellows through the ARGC proved correct. And in November 1985, the Vice-Chancellor's report to Council included 2 grants totaling $98,000 to Prescott, Gregory, Clay and Patterson, a grant of $51,000 to Hocking, Vincent, Elford and Briggs, and 2 grants totaling $65,000 to Thomas and Dodd. Lindsay Dodd from Mathematical Physics. Those grants represented about 10% of the funds won by the entire university, so physics was fulfilling the role it should, winning a large amount of the university's research funds. So with the support of Graham Alford and the ARGC, a small group began to take shape. Tony Williams, sitting up there, was hired as the first research associate in theory. And for a while, with Tony Williams, who just got his PhD at Flinders, Tony Signal, the first PhD student, and myself, you could ask for Tony and you got the entire group. Now, here I will ad-lib because I didn't say what I should have, and I think it's important. It was my intention, and there was perfect agreement with the mathematical physicists, that the level of mathematical teaching within physics needed to be improved. And so there were a number of initiatives in which math physics played a critical role. There were new courses introduced at second year, including one called Mathematical Methods. And I was given the job of replacing Alistair as teaching quantum physics in second year. I think in the first year that those 2 things happened, the students must have wondered what the hell hit them. I know Angus gave them a course that now you would have trouble giving in honours. And in 36 lectures in second year, and I've got witnesses here I met earlier today, I taught them the one-dimensional Schrodinger equation, the 3-dimensional Schrodinger equation, complete angular momentum decomposition for hydrogen, spin, Stern-Gerlach experiment, the Kronig-Penny model, and Dirac notation. Oh yeah, I also taught them Dirac notation. And believe it or not, with this baptism of fire, now you can just do that by the time they finish their undergraduate degree. At that time, there was a group of about a dozen to 20 students who just ate it all up, loved it. And it was a very exciting time for those students. For the others, poor devils, I don't know. Anyway, we've all matured over since then. In the extremely democratic system that Harry Medland's revolution had created in the university, any change required extensive debate within the departmental committee. It wasn't easy, but in the end, the consensus was that the way forward for the discipline was to build research groups of a critical mass, at least 3 or possibly more academic staff. That single decision in the mid-80s is, I believe, the major reason why physics has grown to have such strong and successful research programs. New young staff don't have to make their way in a very harsh funding environment. Nothing new about that, it's always been that way. Totally alone. Group members have colleagues with whom they can discuss issues as they arise, and students have support when a group member is on travel or sabbatical. It works wonderfully. In theory, we made the first appointment, Rod Croutha, whom I'd first met a decade earlier when he was a staff member in Theory Division at CERN. His impact on the teaching programs and through his teaching on the research programs in the department has been and continues to be extremely important. It's fascinating to reflect that about this time the Vice-Chancellor distributed a paper, Issues for 1986, in which he canvassed the previously unheard of idea of taking research performance into account in setting the staffing levels in each area, the so-called compact. It may come as no surprise to anyone familiar with university politics that this failed, for the simple reason that the majority of the deans would not benefit. One may hope, not with great expectation, for a more rational discussion in the context of the preparation of the next strategic plan. Now, there are times in the history of a department, like today, when it's valuable, in fact, it's wonderful to reflect on what's happened, the achievements and the successes. And in 1986, Harry Medland, with his sense of history and purpose, ably supported by Graham Elford and a very active committee, decided to organise the Bragg Centenary celebration, 100 years after Bragg's arrival in Adelaide as the elder professor of mathematics and experimental physics. And this departmental photo was taken in that year, and you'll notice a few people who actually weren't on staff. A highlight of the celebration was the presence of 3 outstanding and internationally respected physicists, Frank Close, Paul Davies and Freeman Dyson, all of whom presented public lectures. They also took part in a public forum in which I joined them one Saturday morning. Attendees included Senator Baden Teague, who, although a PhD in history, had studied physics as an undergraduate. I think this departmental photo, which includes all those visitors, is a very valuable historic document. The experience of that visit and the positive impressions of Adelaide were one of the main reasons I think we were later able to attract Paul Davies from Newcastle as Professor of Mathematical Physics. By 1987, following the retirement in 85 of Professor Herbert, or Bert Green as he was always known, who had founded the Department of Mathematical Physics, it had become apparent that funding constraints meant there would be no replacement. It was inevitable, in my view, that the 2 departments should join together, and in 1988 the university created the new Department of Physics and Mathematical Physics, and I was elected as head of that department. The budget, for those who are interested, was about $3 million a year, not too much different from physics now, with no inflation. And the staffing level was about 20 academics. And that's the departmental photo from that year. You'll see Angus and Lindsay, and I'm sure you're there, Peter, but I'm not sure where. I know I'm not, so Albert picked a day when I was away. Where are you?
I think I'm next to Bert.
Oh, yeah, Bert's, yeah. Oh, yeah, you're with a hat. Yep, okay. Anyway, where am I? This was an exciting and critical time. We'd put 2 departments together. We'd created a new department, and we had the opportunity to make 2 new professorial appointments. with Angus Hurst and John Prescott, both of whom had given tremendous to the university about to retire. We advertised a chair of experimental physics and a chair of mathematical physics. Jesper Munk was appointed to the first and Paul Davies to the second. The appointment of Paul Davies, who'd already participated in the Bragg Centenary, offered the possibility of I'll make up for it in a minute. The appointment of Paul Davies, who'd already participated in the Bragg Centenary, offered the possibility of renewal and expansion of the research program in gravitation and fundamental quantum physics. In addition, his fame as a communicator of science to the general public was seen as an important addition to the department and the university. No one anticipated the effect of the Australian cultural cringe, at least that's my take on it. The Australian cultural cringe is that when anyone is paid attention by the British press, they become immediately the darling of the local media. Soon after arrival, Paul found himself the centre of attention of media all round Australia in a way that hadn't happened in the UK. I often think of it as akin to riding a tiger. And in the end, that side of his career took over at the expense of teaching and research. We heard a little bit about the things in physics that Paul did, but clearly he was pretty soon taken away into writing more publicly accessible books and speaking to public audiences and spreading the word about physics. By the time Paul moved on, the Dawkins destruction of the tertiary system, that's a mild way to put it, had cut into staffing numbers in the department to such an extent that his chair couldn't be refilled. And there's a process whereby hurtful times really get hidden by parts of your brain. And so I'd completely forgotten, Peter, that we went through a process of trying to fill the chair. But when that failed, there was absolutely no hope. On the face of it, the search for the new chair of experimental physics presented a greater challenge, as a world-class appointment in a new experimental research area required a substantial investment in laboratories and equipment. I approached the state government with the proposal that the appointment should be in either solid-state physics or optics. And perhaps because of the strength of the local optics industry and possibly also defence interest, they were willing to support optics. Their offer of $250,000 required matching funds from the university. And here the Vice-Chancellor, Professor Kevin Marchbanks, showed real leadership. I recall the meeting with him in which he simply said, "Of course we must do it." I don't know how he got it through Education Committee or the finances in the university. It didn't matter. He just said, "We'll do it." With those two minor miracles, we had $500,000 to attract the appropriate candidate. Now, even at the process of shortlisting, we had an incident which I've never told Jesper about that could have changed history. One of the panel members took the application from Jesper and placed it in the discard pile with the comment, "No teaching experience," since he was working at TRW in California, not a university. I don't recall exactly what it was in the application that prompted me, but I moved it into the shortlist pile. Certainly I knew the SA government had an interest in providing support to local optics companies, and later I recall an enormous sense of relief during Jesper's lecture in the Kergrant Theatre when his infectious excitement over nonlinear optics became apparent, and it was clear that he would make an excellent appointment. The final process of convincing him and his family to move so far included 2 visits to Los Angeles, where I was a guest at his house. Apart from the superb work that Jesper carried out and the young staff that he attracted, this appointment certainly formed a solid foundation, at least I believe, on which the later appointment of Tanya Munro could be made. Just to show you that Jesper's not always dressed in a tux and we're not always working, you'll be relieved that I cut out the budgie smugglers. But the unedited photo will be in the archives for those of you with a prurient interest. Now, during my time as head of department, head of physics and mathematical physics for the first 4 years, it always seemed that the appointment of the second lecturer in theory took a backseat to more important things. But in 1993, we were finally able to appoint Tony Williams from Florida State University, where he'd been employed in physics and in the Supercomputing Institute. Tony's expertise in high-performance computing was to prove tremendously beneficial to both research in theoretical physics and to high-performance computing in the whole state. Now, at this point, I'm reminded that the physics department didn't exist in isolation, but was a vital part of the university. As a university council member who was young enough to still play cricket, I was asked by Chancellor Bill Scammell, one of the best chancellors the university's ever had, to captain the university team in the Town versus Gown game. So let me show you that. In 1994, the Town team was captained by a very capable batsman. I think he made 60 on the day and almost won the game. He was also Minister for Education, Rob Lucas. And our narrow win was somewhat fortunate. Well, actually, I engineered it, but don't tell them. It's a pity we don't have more activities like this which bring the university and the leaders in the city into informal contact more often. As fortune would have it, my term as president of the AIP was dominated by the preparation of the first strategic plan for physics in Australia. Bob will certainly remember that. Almost every editorial of The Physicist, and this is the first one, involved some mention of the need for input or the latest suggestions that had been made concerning the strategic plan. It was a very public thing. A good deal of the reason for the strength of optics in Australia, I think, can be traced back to a recommendation in that plan. The plan also recommended the creation of a National Institute for Theoretical Physics, and as a result of a national competition, the University of Adelaide was chosen to host it. The very negative reaction to that decision from a former president of the AIP, Tony Klein in Melbourne, was a little sad, but in spite of that, we set out to make it happen. And in this context, you can see just how important visionary leadership at the top can be. Both the Vice-Chancellor, Gavin Brown, and DVCR Mary O'Kane were strong supporters of this initiative, setting aside ideally suited office space at 10 Pulteney Street. So this is the launch of the National Institute for Theoretical Physics. Forgive my hair. That's the governor who came to look over what we were doing, along with Tony Williams and Mary O'Kane. Despite our best efforts, which included the organisation of many national schools and workshops, the Australian Research Council never proved able to provide necessary financial support for NITP. However, our work and the support from the university wasn't wasted. This is another shot from the opening of NITP, actually. Because in 1996, Tony Williams and I succeeded in winning an ARC Special Research Centre for the subatomic structure of matter. Sorry, I had one more shot from NITP. This was the first of a series of workshops organised. This one involved a joint meeting between Australia and Japan. And there were a number of really outstanding people from Japanese subatomic physics at that meeting. Those of you who know the field will recognise some of them. Now, the idea of the SRCs was to give a small group of top-rate researchers the freedom to develop their research for a period of 9 years without the need to worry about funding. What more could you ask for? So that's the letter from Mary O'Kane accepting the money. That's the actual presentation of the centre in Canberra at ARC from Amanda Vanstone, another Adelaide graduate. In establishing CSSM, we were unbelievably fortunate to attract outstanding staff, and that included Sharon Johnson as my PA. I have to say, Sharon had worked for David Beecher, and then she had a kid, and she wanted to come back and work half-time, and the administration at that time wouldn't let her. And she worked for us part-time, and then she decided, well, after a year, she had to choose whether to go back to work full-time in the registrar's office or work for us part-time and lose her tenure at the university. And she chose to come back and work for us part-time. And that sort of dedication is, that should be required is well, it's unbelievable. I could use stronger words. But we benefited. We also had Ramona Adorjan as our computing officer. I think we shared the salary with the department. The first academic staff member we hired to replace my teaching in the department was Derek Lineweber. Some of you have heard of him. He was an outstanding young practitioner of lattice QCD, which was one of the key research directions Tony and I had agreed on. Derek's contributions to the university as head of physics and chemistry are known to all. Now, already in the mid-90s, it became apparent to me in the post-Dawkins era that with student-staff ratios in science heading from 9:1 to in excess of 20:1, university funds alone could not support the necessary infrastructure and technical support, let alone support expansion in new directions. We've heard today about the numbers of technical staff groups had in the past, and we just can't do that anymore out of university funds. Now, in spite of that, and here I have to show you a couple of other things. I've talked about CSSM, but let me show you a couple of other things. Archaeometry in the 90s was doing important work, and Nigel Spooner sent me this cover from Nature, highlighting work done here in Adelaide by John Prescott and his collaborators, along with Nigel, who was at ANU at the time. And the Kangaroo Project I have to mention, because in a sense it's a forerunner of HESS and some of the things that the High Energy Astrophysics group is doing now. Also because every time I go to Japan, even now, colleagues, theory and experiment, always ask me about Kangaroo, because they remember this joint project. And it's fascinating to know that when it was opened, it not only had our Vice-Chancellor, but the Ambassador of Japan to Australia at the time, and of course the lead CI from Japan, Professor Kifune. Anyway, I was starting to tell you about the need to win external funds. Unfortunately, for several years after the departure of Mary O'Kane, the senior administration at the University of Adelaide was in shock and didn't understand it. It led to the appalling situation in 2002 when a new research institute, WISER, World Institute for Space Environment Research, which had strong research support from the US Air Force, excellent international connections, for example, in Japan. I show you a slide from one workshop that Abraham Chan organized in Tokyo. And we lost an extremely creative and dynamic director back to Brazil when it failed to receive university support. Worse still, and I'll stop the negativity after this, but I have to say one thing. At a review, and once again it's a review where the disasters happen, of CSSM in 2002, in which 3 of the world's leading nuclear physicists came to Adelaide and gave an unambiguously glowing report of what was happening, the response of the DVCR was, "That's wonderful, we just hope we can afford it." Attitudes like that led me to accept the offer to move to Jefferson Lab, one of the US Department of Energy's 2 major nuclear physics labs, as Chief Scientist and Associate Director of Theoretical Physics. Now, already by the time I left in February 2004, oh, and by the way, a lot of people lost bottles of wine over bets on that around the world. By the time I left in February 2004, these attitudes were beginning to change, thank God. Through strong support at Council and from the Vice-Chancellor, I was allowed to retain the title of Elder Professor of Physics, which I'm proud to have held since '89. The appointment of Tanya Munro, which has led to some incredibly exciting developments in research across the whole university, occurred around this time. Tanya didn't take up her appointment until early 2005, and so we did not actually meet until considerably later. The comparison between support for research in 2004 and 2009, when I decided to return, was a comparison between night and day. With Derek Lineweber as head of school, Mike Brooks as DVCR, and James McGuire as Vice-Chancellor, the decision was easy. The university's support for research institutes such as Tanya's IPAS and university research centres such as the reborn C-squared SSM is now exactly what's needed to support winning those external funds which are crucial to research success. It was certainly crucial to the success of my application for an Australian Laureate Fellowship, and most recently for the new ARC Centre of Excellence in Particle Physics at the terascale. So where does the discipline of physics stand at the current time? In my view, it's stronger than it's ever been. A brief summary here. Overall ranking in our ERA 5, over $4 million in Category 1 grants this year. Total research income over $6 million. That's actually double what it takes to put together the few academic staff and the entire teaching program. So you've got this tiny little thing which is the center of an enormous strength of research. It's a very strange system, but that's what we live in. And of course, $34 million over the past few years through Tanya's efforts in external funding for the Braggs. In optics and photonics, and in these slides I've picked only the staff, the lecturers in and above in the areas. I apologize that people like Judith Pollard won't appear here, and her contribution to the teaching of the department is vital. And of course the research fellows, and of which there are many, without whom none of the research would go on, don't appear in these pictures. Many of them appear in the material at the back, in the backup slides. In optics and photonics, Tanya Munro has proven an outstanding leader, managing an incredibly successful research institute through which her, and this is her phrase, I think, transdisciplinary approach to problem solving has not only won large amounts of research funding, but has also generated first-rate publications and innovative new devices. She's developed even further the strong relations with the optics industry and defense that Jesper Munch succeeded in building, as we hoped at the time of his appointment. This group also plays a very significant role in the LIGO project. So let me just take you through a few slides that I was given by the group. There's a recap of history. The two young people I mentioned aren't so young anymore, but they're still pretty vital. And you see some of the research that was involved. They put in some pictures of early PhDs. Some of the things that they've built, 10-watt lasers, 100-watt lasers, the world's highest brightness, high power cryogenic laser. And then we have IPAS, a major transdisciplinary research institute. There's a whole page of very tiny photos of the people associated with IPAS in the backup slides, which I decided not to put here. Some of the highlights with applications of optics across many areas, from medicine to defense, food and wine, are all here. I don't know whether Tanya gets spin-offs in terms of the wine that she tests. I hope so. And of course, we're all aware, and I can mention it now that Harry's not here, the Braggs building, which will be the headquarters for IPAS and due for completion fairly soon. And finally, I just mentioned the LIGO project. In terms of fundamental science, this is really exciting. One hopes that in a couple of years we really will see for the first time direct evidence of gravitational waves. The high energy astrophysics group we just heard about from Roger, it's developed in multiple directions since its foray into meaningful international collaboration with the Kangaroo project in the 90s. While Kangaroo is officially finished, in some sense it led to the HESS project in high energy gamma ray astronomy in Africa, in which we're actively engaged. There's also a substantial role in the Auger detector, which is searching for the highest energy cosmic rays, and finally the group's involved in the ice cube neutrino detector in the Antarctic, to which you are thoroughly welcome. The science is exciting, but you're not going to get me down there, I'll tell you that. Under the leadership of Bob Vincent and Ian Reid, the atmospheric group has contributed to the... Oh, sorry, I needed to show you something about Pierre Auger too. I think the one slide you want to see is the name and the picture of what's happening to the Earth. It's frightening, really. Under the leadership of Bob Vincent and Ian Reid, the Atmospheric Physics Group has contributed to the development and application of radars to study, now here I'm reading what they wrote me, and my God, to study the structure and dynamics of the atmosphere and ionosphere from the ground to geospace. Now I understand all of that except geospace, and someone's going to have to tell me what it is afterwards. It includes the Super Darn over the horizon radar, meteor wind radars, and boundary layer and stratospheric wind profiling radars. The group created a very successful spin-off company, ATRAD, which sells radars designed in Adelaide nationally and internationally. And some of that's summarized on here. You can see these slides later. it's hard to show them. Some of the applications, their wind profiler at Sydney Airport is probably pretty important to all of us, those of us who go in and out of Sydney Airport from time to time. Studies of tropical storms. And through ATRAD, it actually looks like a disease, but it's not. ATRAD has put radars all around the world, and in a time when global warming and understanding climate change is so important to all of us, the tools that are being provided out of Adelaide are clearly of great importance. The atmospheric group has also developed and applied optical techniques, including LIDAR, to study the thermal structure and dynamics of the middle and upper atmosphere. And finally, in collaboration with colleagues in France, they've studied the destruction of ozone and the lower stratosphere of the Antarctic. Finally, in subatomic physics, the theorists continue a broad program of research in which lattice QCD and phenomenology are brought together to confront the outstanding questions in modern nuclear physics. Recent achievements include the determination of the contribution of strange quarks to the mass and form factors of the proton, a problem of comparable importance for QCD to the original calculation of the Lamb shift in QED. Innovative lattice techniques have led to new insights into hadron spectroscopy, while the equations of state of dense matter have been shown to have profound consequences for the structure of neutron stars. Most recently, with the creation, so I'll give you a very brief history, most of that I said. A brief summary, 78 graduate students since CSSM started, 54 honours students, 46 undergraduates involved in research projects, 370 articles, a lot of paper, and roughly $1.7 million per annum in Category 1 grants this year. And now we come to the last point, which Tanya will be very pleased to hear. Most recently, with the creation of the ARC Centre of Excellence for Particle Physics involving Adelaide, Melbourne, Monash and Sydney universities, Adelaide University was able to make its first appointment in experimental high energy physics, Paul Jackson, who came to us from employment at Stanford via CERN. Only in June this year was Adelaide University accepted into the ATLAS collaboration at the Large Hadron Collider, just in time for us to be the first institution listed on the paper from ATLAS describing the discovery of what is almost certainly the famous Higgs boson. Theoretical work through that centre in Adelaide is not only supporting the experimental program, but pursuing fundamental theoretical ideas from supersymmetry to the nature of dark matter and this fantastic dark energy we heard about earlier. Together, these research programs, so let me just take you through a couple of slides on the Particle Physics Centre. What we're about is exploring the nature of matter, the matter that was there less than a nanosecond after the Big Bang and as early before that as we can go. The big and the small are intimately connected, and the large-scale structure of the universe is almost certainly connected with what happened in those early stages of the development of the universe. This is the ATLAS detector, about which Paul will, I'm sure, tell you till your eyes close over. It's a big detector. These are not Swiss dwarves, they're regular people, I'm told. And they like, you know, there's nothing, they like to think of what they're doing as important, so this detector is roughly 1/4 of the size of Notre Dame Cathedral, in a comparison that I like very much. This is a famous picture, one of the many famous pictures from the last month or so. It's one of the critical events which helped to establish that the Higgs boson exists. Inside this giant detector, many things go on, but here you see the 4 red lines, 4 high-energy muons coming from a single point, which is interpreted as the decay of the Higgs boson. It's a wonderfully challenging and exciting time for subatomic physics, and clearly the next decades will offer tremendous opportunities. Together, the research programs that I've described to you represent a remarkable effort to explore nature at its deepest levels, while simultaneously contributing to the defence of Australia and the health of local industry. In my view, the university and the people of South Australia have a great deal to be proud of when it comes to the discipline of physics at the University of Adelaide. Thank you.